Hi, this is Saurabh Suman, and this is the assignment for Course 1 Machine Learning Foundations by Duke University. So, we can see we have a data which is known as CCPP data CSV file, where we have four input features and there is one output feature which is PE. So, this data, as we can see, is the input features are kind of continuous in nature, and there is no feature which is kind of a classification in nature. So I think we can use regression model in order to train our model and predict the results. In order to attain our model, we'll be using CRISP-DM process, which is a process model that serves as a base for data science processes in many industries. So, first of all, in this process, we'll be doing business understanding of what exactly we need to do. After that, we'll be understanding data. After that, we'll be doing data preparation. Then we'll be doing modeling, and at the end, we'll be doing evaluation with the help of matrices. So the business use case over here is we have been provided with a four feature which are kind of continuous in nature, and basis that we have to predict the PE value. So there is approximately 9,500 records in this particular data. The input features are temperature, ambient pressure, relative humidity, exhaust vacuum, and the target variable is net hourly electrical energy output, which is PE. Now the second step is the data understanding. We have to find out how these input features relates with this particular target variable. Does it relate linearly or non-linearly? For that, I have used a couple of methods to find that thing out. So I have plotted the graph against each input variable versus the output variable to see if it can relate linearly or not. So as you can see over here, the variable AT and power output, it kind of relates linearly. The variable V and PE, it can also relate linearly. Similarly, AP and PE can also relate linearly. While the RH variable, the RH input feature, is very less related linearly to the output variable, which is PE. So basis these are above observations, we can conclude that the input variables, the three of them are highly related linearly with PE, while RH is aligned towards a non-linear relation with PE. So basis that we'll be using linear regression model, the multivariate linear regression model, to test our model. So this will be the first approach. The second approach will be will be removing this RH variable from our input, and then again we'll be testing this. So as you can see, the first model we have uh, the input features, the all four of them. We have splitted the data 80% to train and 20% to train. Okay, and in model 2 we have removed the RH variable, and then again tested splitted the data 80% to train and 20% to test. So The output of these two models lies in this particular variable ypred underscore m2 for model 2 and ypred m1 for model 1. Over here, I have tried to calculate the four output matrices to evaluate our models, which is RMSE, MAE, MAPE, and R square. We can see these values for model 1 and these values for model 2. So we know that for a better model, the RMSE, MAE, and MAPE value should be lesser in order to perform better. On the other hand, R squared should value should be higher. So we can see that model 1 suffices that condition. Basis that we can conclude that model 1 performs better.